Hi, I'm Cal Christian Estrellan, and today I'll be presenting a project for Electronic Circuits Laboratory about the Mosfet amplifier circuit, or also known as the metal oxide semiconductor field effect transistor. So, what is a Mosfet amplifier? A Mosfet is basically a transistor which uses field effect and it has a gate, drain, and source connection. So here we have the design of the circuit. We have one voltage source, four resistors, three capacitors, and a MOSFET component. So the advantages of a MOSFET is that MOSFETs provide greater efficiency while operating at lower voltage consumption. The absence of gate current results in high input impedance, producing high switching speed. They operate at lower power consumption and draws no current. So for the disadvantages of the MOSFET is that the thin oxide layer makes the MOSFETs vulnerable to permanent damage when evoked by electrostatic charges. It has low transconductance, and overload voltages makes it unstable. Thus, it has a short life. So, to plot the waveforms of the input and output of the graph, we will use the SPICE directive .tran 01M0. We paste it here. Now we run the circuit and probe V in, add another plot line to probe V out. So now we have a visual representation of the waveforms of V in and V out. For the measured parameters of power, bandwidth, and amplification factor, we will be using the commands in LTSpice. So to get the bandwidth, we will use .mesh for measure, T1 find time when V voltage input is equal to 0.5 M. Now control M for the new line. Measure T2 find time when voltage input is equal to 0.5 M cross equal to 3. Now for its frequency input, measure frequency input and its parameter with a formula of 1 over T2 minus T1. Now to measure the peak-to-peak values of voltage and current, we'll use the commands for the peak-to-peak voltage, which is measure tran voltage output peak-to-peak of voltage output, and another one for the voltage input. Tran voltage input peak-to-peak, V voltage input. Now we need the voltage gain of the output and input peak-to-peak. For that, we will use measure AV for the voltage gain and the parameter of voltage output peak-to-peak and voltage input peak-to-peak. So this serves as the amplification factor of the circuit. For the current peak-to-peak, same goes to the voltage, but we will use I. So that measure tran current output peak to peak, I capacitor 1, and measure prime current input peak to peak, IRL. And for its current gain, we will use dot measure current gain parameter of current output peak to peak and input peak to peak. So same goes to the voltage. This is the amplification factor. Finally, to get the power, we will use the values of the voltage gain and current gain. So for the SPICE directive, we will use that measure power gain and the parameter of formula voltage gain times current gain. Now to show the simulation results, we will run and view the SPICE error log. So run by clicking this running man and view the SPICE error log. So as we see here, we have the extracted values of T1, T2, and the frequency input of 9986.27. We have the extracted values of voltage output peak to peak and voltage input peak to peak with the voltage gain of 0.0535224. For the current output and input, we have these values and its current gain will be 1.56007. Now for the power gain, it was multiplied by the voltage gain and the current gain equal to 0.0834984. So that will be all for now, and thank you for watching.